Welcome to the Google Cloud Security Showcase, a special web series where we'll focus on security use cases that customers can solve with Google Cloud. My name is Aspen Cheryl, and I'm a cloud security architect at Google. Today, we're discussing VPC Service Controls, or VPCSE in short, our solution for preventing data exfiltration from managed services in Google Cloud. Specifically, we'll be discussing some best practices for auditing VPCSE logs, and we'll go over some strategies for allow listing legitimate flows. For context, the content that I'm covering here assumes you already know the basics of how VPCSE perimeters work. So your perimeter is defined, you have your projects and your protected services, and now you're seeing violations and you have to start allow listing flows before you can move to enforced mode. The first piece of advice that I'll give you is that auditing VPCSE logs is very similar in concept to auditing firewall logs. The nomenclature and moving parts might be a little different, but in essence, you need to know where the traffic is coming from, where it's going to, and who is trying to do what. Now, VPCSE at this point in time is managed at the org level by default, but enforced at the project level. That means logs are surfaced within each individual project where a violation occurred. I strongly recommend either setting up your own log syncs and exporting those logs to a SIM, or using the new VPCSE reporting dashboard, which is preview at the time of this recording. For POCs, auditing project by project may be doable, but for most real-world deployments, you're going to want to get those logs aggregated in a human-readable manner. For this video, I'm going to be using the preview dashboard. Part of the reason aggregating logs is so helpful is because it gives you somewhere to start. Seeing which projects and which services have the most violations lets you identify where your auditing efforts will have the most impact. Obviously, if the business gives you a mandate for a high priority service, you would start there. But if you're starting from scratch with no guidance beyond get or done, this is a good way to start. For this video, as I said, I'll use the new built-in dashboard, and let's go to that view now. All right, so in the dashboard view, you can see I've got a decent little number of violations here. So I'm going to come down, look at my aggregations, and there's a few different places I can look to start. So first, I can look at the top services that are causing violations, and I see the artifact registry is a heavy hitter here. I could look at the IPs that the requests are coming from, or I could look at the identities involved in generating these requests. Then I could come down and, oh, look at that. The vast majority of requests are coming from my RSA demo project. So that's a good place to start here. So I'll come into resources and I'm going to filter on my RSA demo project. All right, so now I'm only seeing my RSA demo project and I'm going to look at some of these services here. I see Cloud Run, I see Cloud Functions. Let's see, Functions, Logging, Artifact Registry. Okay, so my top violations by service haven't changed. Artifact Registry is still the top service. But I see that Cloud Functions is way up on this list here, and that tells me a few things. Because I know that Cloud Functions is a serverless service, and it has dependencies. Obviously, if you're newer to Google Cloud, that may not seem intuitively obvious to you. So what you can do for services that you're looking at on this list is you can identify the service, and then I'm going to go with Cloud Functions here because it's a good example for this. I'm going to pop into the supported products and limitations page, and I'm going to do a search here for functions. And here we go. Cloud Run Functions, because Cloud Functions v2 is built on Cloud Run. Now I'm going to look at these caveats and limitations as documented, and I can see right at the top, Cloud Run Functions, which is Cloud Functions v2, uses Cloud Build and Container Registry, which is Artifact Registry, and Cloud Storage. All right. And if these services are restricted by a VPCSE perimeter, it'll block the function build, even if functions are not added as a restricted service. So the pertinent information here that I really care about is to use Cloud Run functions inside a perimeter, you must configure an ingress rule for the Cloud Build service account in your service perimeter. Back in my dashboard here, looking at this identity, I'm pretty sure I know what that is, but I'm going to trust but verify. I'm going to pop into IAM, enter that identity, and sure enough, default compute engine service account. Cloud Functions and Cloud Build by default use the default compute engine service account. Now, obviously, this is a little demo environment, so this is fine. But in an actual production environment, you're generally going to want to spin up your own bespoke service accounts for these services to use. But all right, so I know what that identity is, and I know what it's doing. It's sitting here trying to execute the function and pushing the container containing my function into Artifact Registry. And then as I'm making modifications to my Cloud function, it is updating the container accordingly. So all right, I have my documentation. I know what I need to do. I need an ingress rule for the Cloud Build service account, which in this case is the default compute engine service account. All right, I've got my identity here. I can come into my service perimeter. This is my RSA demo perimeter, which you can see contains my RSA demo project. I'm going to edit this perimeter, come down to ingress policies, and add an ingress rule. Cloud Functions ingress. My entity. My identity will be that service account. And again, in your production environment, this should be a bespoke service account specifically for Cloud Functions and Cloud Build. And source here, because Cloud Functions is a serverless service and Cloud Build is also a serverless service, it is running in what's called a tenant project, which is a project that Google spins up and maintains, which is inherently outside of your own organization because Google owns it and manages it. So the reason we need the ingress rule and the documentation specifies so is because the request is coming in from a project that is indeed technically outside of your org. It's Google. It's coming into your environment to do the serverless services job. So that project is potentially and likely ephemeral. So we can't allow by that project. We can't allow by the IP. And it should only ever be coming from a Google project, so I'm not too concerned with restricting the source. And, if I wanted, I could go ahead and lock down projects that the service account could access. But for my purposes, I'm going to go ahead and leave it. Here's my service account. It's coming from any source and can access any project. So after I've pushed that out, the number of violations that I'm seeing should drop drastically. Because honestly, this is a ton of noise that is being generated from just not having that one little ingress rule for that one little service account. So you can imagine that on a production scale, what that might look like and the number of violations that you might encounter. But by doing this, by going into your aggregated logs and looking at individual projects and then looking at the services that are running in those projects and then checking the supported products and limitations page, you can generally get rid of a lot of that noise pretty quickly. Now, I want to call out that the example I used today was for a Google managed serverless service. But you'll also need to keep an eye out for legitimate flows from things like partners or vendors, like security scanners or IEC tooling. Whenever possible, don't allow list by identity alone. Compromised credentials, especially things like leaked service account keys, are still a leading cause of data breaches. So layer your attributes, like an identity must be coming from a specific CIDR range or from a specific project if the vendor or partner is on Google Cloud. The more attributes you can layer, the less likely a compromised credential could be used to exfil data from your environment. So to recap, aggregating your logs is the first step to auditing and then allow listing for services you're adding to your VPCSE parameter. Look for heavy hitters to get an idea where to start, and check the supported products and limitations page for each service before moving it to the enforced config. And for third parties like vendors or partners, layer as many attributes as possible to reduce the risk from attack vectors like compromised credentials. To learn more about VPCSE, watch our other videos or visit our product page.